Assalamualaikum and hello. My name is Milena Zia binti Zablis and my group mates are Nur Janantun Najma binti Alizan, Amal Irfan bin Shahruddin and Siti Nurhaliza binti Kamazaman. So in this video, we are going to present our problem-based task 1 for the subject Python programming. So it is about a LRT management system. This LRT management system is a Python-based application designed to stimulate and manage light rail transit (LRT) operations through two key modules: a station management system that handles unique station IDs, inter-station connection, multimodal access like railway, bus, and airport, and fare calculations based on distance and cost per kilometer, and a rapid KL transit network system that provides journey planning across multiple transit lines like LRT, MRT, monorail, and BRT, fare computation, and data logging. So data logging is like saving details in different file formats. For example, .txt, .xls, and .json formats. So built using object-oriented programming (OOP) and file handling. This modular system demonstrates real-world transit management with extensibility for future enhancements like real-time data integration for GUI implementation. First, we have the file lrt-demo.py. This is the station management system. This program is called LRT management system. So these are the comments. It states all the details and all. So first we have a class station. Each station object represents a physical LRT station with these attributes. So first is the station ID. It is a unique identifier. And then we have name, which is supposed to be a readable human name, and cost per km, which is the fare rate. Connections is a list of linked stations and distances. And these access flags are booleans for railway or bus or airport access. And lastly, staff ID. So staff ID is an identifier for the staff. The add connection functions is for linking stations bidirectionally. And set access function configures transport mode access. And assign staff function assigns a staff member to the station. Next, we have the class LRT system. This class acts as the controller for the entire network. We have a function in it, and the stations are like a dictionary for storing all stations. And add station function creates and registers a new station. Connect stations functions connects two stations bidirectionally. And lastly, calculate fare functions. This calculates the fare between two stations. So next we have the if underscore name underscore equals to main. This demonstrates functionality. So LRT system initialize the LRT system. So LRT dot add station add stations to the system, and LRT dot connect underscore stations connects all the stations. The dot set access sets the transport access, and assign underscore staff assigns the staff, and lastly we calculate the fare and prints it out. This displays the station info. It loops through all the stations stored in the LRT system and prints out all the info. Finally, we have the input. So this shows all the examples of the code and the output. So first, it prints out the fare from KLCC to Masjid Jamek, which is 1 ringgit and 75 cents. And then we have the info on station KLCC, and the cost per kilometer is 50 cents. And connections is 1. Railway access is false, meaning it doesn't have access to railways. And bus access is also false. And airport access is false. So meaning it doesn't have access to the uh, all of the stated ones. So the staff ID is staff 001, which is the staff assigned to the station. And for Masjid Jamek, it basically uh, repeats the output but with their respective info. So that is all from me. So now my friend Amal will continue the presentation.
Good morning. My name is Muhammad Marifan. So thank you so much for giving me this opportunity to present my Python project. So today I'll be sharing a system that I developed to help streamline and improve public transport, specifically a light rail transit or LRT management system built using Python. So the LRT management system is designed to simulate and manage cooperation of an LRT network. So it includes key features such as train scheduling, ticket booking, passenger tracking, and basic administrative controls. So the goal of this project is to demonstrate how Python can be used to create real-world solution for transportation management. So now we will go through the code piece by piece to understand how everything's work. So first, class ReplicaL. This class define a class named ReplicaL, which is used to represent a station in the ReplicaL transit system. Next, we have initializer or constructor, the init. So this constructor initialize a new object with, for example, line, station ID, station name, cost per kilometer. So for line here, as we can see, self.line. So this transit line the station belongs to, for example, Ampang line. And then we have station ID, which is a unique ID for every stations. And then the station name, which is the station name itself. And then we have cost per kilometer. So this is the fare rate per kilometer for every stations. Lastly, we have connection, which is a lease, empty list to potentially store other connected station. So next, we have station details. So for this one, uh, the method itself to write the station details to a text file name, which is stationdetails.txt. So it appends, but it won't overwrite anything, uh, information in a readable format. So next we have station. Right, so next we have static method. So this method doesn't rely on any instance of the class. It prints and writes all the service lines and their link to a file called transitdetails.xls, which is Excel. So it includes LRT services, MRT services, monorail, and also BRT, which is bus rapid transit. Then it saves all the info into a file, which is the transit details file. Even though XLS usually means Excel, this is just a plain text file with the extensions. So next, we're gonna look at the calculations. So here is the calculations. So define calculate fare. So this is basically a simple function calculates the total fare of a journey by multiplying the distance with the cost per kilometer. And then we have define display menu. So this function just prints out a menu showing available transit services and lines with their distance, useful for user interface or command line interactions. So that's all from me. Thank you.
Assalamualaikum, my name is Nurjan Rajma Binti Aliza, matrix number F1067. So now I will continue to explain the codes. So for the user journey function, so we first define the function user journey, and then we call the previously defined function, which is display menu, to show the menu to the user. Next, we start an infinite loop to keep asking for input until valid input is received. Then we begin a block to handle potential errors, specifically if the user enters non-numeric input. And then for line 91, prompts the user to select a line that attempts to convert the input to an integer. And then we check if the number is within the valid range 1 to 7, and if yes, break exists the while loops. Next is print. If the number is valid, print an error message. Then for the accept value error, if the integer conversion fails, like user types text, this block cache the value error and print an error message. Next is prompts the user to enter their starting and destination names. And for the line 102, we define a list containing the predefined length distances for each line corresponding to the menu options. For the line 103, select the correct distance from the line distances list based on the user's choice. We use user choice 1 because list indices start at 0. And for the line 105, we returns the collected user choice and start station and station and the determined distance. So finally, a function to display the calculated journey details in receipt format. So first we define the function print receipt, which takes all the necessary journey details as arguments. And for the lines 108 to 115, these lines print the journey details, line start and distance fare to the console, formatted nicely as a receipt. Note the formatting for distance and fare. Now we reach the main part of the script that runs when the file is executed directly. So, for the line 118, this is a standard Python construct. The code inside this block will only run if the script is executed directly, not imported as module into another script. And for the line 119, we start a try block to handle potential error during the execution of the main logic. And for line 120, calls the static method of the rapid get-out class to display and save the general transit information first. For the line 121, we calls the user journey function to get input from the user and unpacks the return value into corresponding variables. For lines 123 to 124, we create a list of lines name corresponding to the menu option and then select the actual name of the line chosen by the user from the line list. So now we continue with line 128. So this is where we create an instance of the rapid class. We pass the selected line a formatted station ID, the start station name, and the hard-coded cost per km of 0.5. And for the line 129, we call the calculate fare function, passing the distance obtained from user journey and the cost per km stored within the journey object. The result is stored in the fare variable. Next is for station details, because the station details matrix on the specific journey object we created, this saves the details of this particular journey to station details.txt. And then call the prereceipt function to display the final receipt of the console using all the calculated and collected information. And then for line 138 to 144, opens a file name for details.json in append mode A and writes the journey details line start and distance file to it. And then for exception, if any error occur within the try block that wasn't a value error card earlier, this general accept block catches it and bring a generic error message to preventing the program from crashing. I think that's all for me. Now I will pass to my friend, Haliza.
Assalamualaikum and hi, my name is Siti Nurhaliza binti Kamazaman. My number matrix is F1172. I will be the last presenter for today. So I will explain about the output. When I run the program, the first thing is just display all the available service and line, including LRT, MRT, monorail and BRT. Then the user is asked to select the line by entering the number 1 to 7. So, for example, I put 3, mean I choosing the Kelana Jaya lines. After that, the system asks me to enter the starting station and the destination station. I put KLCC. The destination is Pasar Seni. So, once the station are entered, the program will automatically get the distance based on the line choose, multiple that distance with 50 cents per km, and then show the fare. For example, the kilometer Pasar Seni is 46.4 km, then you need to multiply with 50 cents equal to 23 get 20%. This way, journey information is shown as the receipt on the screen and also save into 3 different files. So, I will explain about station detail code. This part of the code, we start with open. This line open a text file called stationdetail.txt in append mode, so we can add new information at the bottom without delete the old data. So for f.write, this line write the line name into the file, such as a Siri Petaling or the output is the KLCC. It also add a new line after writing. For the f.write f station ID, the write the station ID that it automatically generate like ST01 or ST0T and so on. For the f.write f form, they save the starting station name to the file. And then for the f.write cost per kilometer, this write the cost per kilometer fits at 50 cents and format is nicely to decimal places. So for the transit detail, this open the transit detail.xls file. The W here mean write mode, so it create a new file or overwrites and exiting ones. For the f.write service LRT/N, this line write the type of service like LRT, MRT, monorail and BRT. For the f.write line Ampang length 45.1 kilometer, then it write the line name and the total distance in kilometer. Finally, this line write 30 dashes of the separate each station nicely, making it file easier to read. Lastly, for the file detail, we have this open the file detail.json file append mode, so we can keep editing new journey detail. For the f.write f journey detail, this add a small heading journey detail to show the start of the new record. For the f.write f line, this write which line the journey is on. For the f.write f from, this write the starting station, and for f.write to, this write the ending station. And for f.write distance, it write the distance between station round to the 1 decimal place. And for the f.write fare, this write the calculate fare based on the distance rounded to 2 decimal place. And lastly, we have this add a line of dishes to clear separate each journey. f.write dash plus 30. So in the conclusion, this Rapid KL Transit Network System project showcases how Python can be used to simulate a real-world application by combine user input, object-oriented programming, and file handling. It allows user to interact with menu, calculate fare based on the distance and cost, and automatically store journey data for future reference. The use of 3 external files, station detail, transit detail, and the fare detail, reflect how data can be organized, stored, and reused efficiently. Overall, this project demonstrated how we can use programming not only to solve problems but also to simulate real transport system in the practical and user-friendly way. Thank you. That's all from us.